Hello everyone, it's July the 5th. Alright, Monday, let's do this. It's supposed to be something not too hard. Alright, reshape the matrix. Oh, reshape the matrix. In MATLAB, there's a handy function called reshape, which can reshape n by n into a new one with a different size, keeping its original data. You're given n by n, and two integers representing the two rows and column numbers. The reshaped matrix should be filled with all the elements of the original matrix in the same row traversing order as they were. As a reshape operation with given parameters is possible and legal, output the new reshape. Otherwise, output the original matrix. So here is good. This is not possible because input is 2 by 2 and output is 2 by 4, which I think we can just cheat by import NumPy, and what we can do is say if mat equals numpy.array mat. Actually, it's interesting. I don't know. Like, what will NumPy do if the shape doesn't match? I guess they will say it's wrong. Let's see, numpy.array. Let's just do 1. Right, so 1, 2, and 3, 4. That'll be a 2 by 2. I forgot to say a equals, right? And then I say a.reshape. A.reshape. Let's say 2 by 4. I think it probably throw an error. Yeah, so we can try it. So what we can do is also a dot. I think has a to list. Yeah, so we can do try, right? Try numpy.array.reshape row and columns. Try return reshape.toList and except doesn't matter. We're gonna return mat. Right, I think that's the one to go. Oh, why are you taking so long pending? Oh, why? I don't know. Did it import the NumPy take a long time? Oh, maybe they intentionally don't let you pass this way. No, they do let you pass. But yeah, they let you pass, but pretty slow. But anyway, so that's not the purpose, right? The purpose is to try to do it ourselves. I mean, for one thing, it's the try block. That's going to take a while, right? So the one thing is we get the row number, column number. We can immediately decide whether it's possible or not, and then we set it up and we just go through everything. Yeah, I think it should be pretty straightforward. Unless there's a better way that I do not know. Anyway, so here is our solution without relying on NumPy. I don't know why NumPy is so slow. Like, there's overhead setting things up. That's the only thing I can think of. So, mn equals lammat 0. Hold on, yeah, it's 1. And then we say if m times n is not equal to r times c, right, then we return mat. Otherwise, we say res equals to 0 times number of columns for in range number of rows. And then we're going to say how do we say that? I mean, we're going to iterate through this. I mean, if we can flatten this, that'll be easier, but we have to do it 2 rounds. Can we just do 1 round? As we go through, we count, right? Then we keep adding until the rows, right? Until the rows. If it doesn't reach it, that's fine. If it reaches it, and we'll go to the new row, then we just do, we do column. I think it's it's a row. So row I times column plus j. Right? That's I times column plus j. And then that is the index in a 1 array. And we do that mod, right? We do that thing mod the current row, the row number of the new matrix, no, the column number of the new matrix, right? And then once it reaches the end, it just means once it equals, and then we plus 1. Yeah, I think this one shall work. So what I'm going to do is for I in range m, for j in range n, we're going to say jj, start with 0, 0. We say res, right, jj, hold on. I is computed, we just need jj. So I is computed by I times n plus j, and this whole thing we're gonna mod column, and then jj, no, jj is a column. Yeah, this is wrong. This is column. So this is column. We can do column, so it's have to be I. Row we need to handle. So we're gonna say this going to equal mat ij, right? And after that, we say, let's do this. Jj equals to more explicit. So this is jj, right? And after that, we say if jj equals column minus 1, which means we go to the end, then I plus equal 1, and we return the rest. Alright, let's run the test case. 1, 2, and 3, 4. 1 and 4. It shall give us 1, 2, 3, 4. Alright. Next one, same thing. 1, 2, 3, 4. But we have 2 and 4, which give us 1, 2, 3, 4 still. So mat RC, and this is a matrix reshape mat RC. R range, spelled wrong, range. Alright, let's try this one. So this is numpy solution. Pending, accept it. Yeah, that's how it's supposed to be. Alright, so must be an easy question. Use the I times n plus j, right, plus j, mod C trick to obtain the column index in the new matrix from any value in the old matrix. That's OMN or ORC. It doesn't really matter. They're all the same. OMN, where M and N are the row and column numbers of mat. And we hit 88 milliseconds or 65. Yeah, I don't think there's anything more to this, unless, I mean, this is necessary. This is, I mean, iterate through everything and then put it in. Yeah, I think that shall be it. Follow the tradition of Monday being an easy question. 566. 566. All right. Good question. One loop, one pass. Is that considered one pass, right? Okay, so what we have is, we do a product. Product works. Count divided by C. What is count? Oh, count. Oh, they use count. Count divided by C, and count mod C. C is column. So this one gives us a row. This one gives us a column. It's fine. It's fine. It's same idea. So just count, keep going. All right. That's it. That's it for today. I mean, we have slightly different implementation here, but it's just the same thing. I'll see you guys tomorrow.